Hi, today we'll talk about quadratic function. This is our group. I'm the first person, and actually, the normal one is the normal function is like this, and the graph of this one have two different types. If A is positive, it will be like this one, and if A is negative, it will be like another group. And you can see it have two x with this one, and they all have the midpoint. This one have the minimum point, and this one have max point. They all follow one function. They all follow this function. So if we want to know another, like this point, we can follow another one, and I will pass to my next group.
I'm the second member of this group. We use this equation to find the minimum point or the maximum point of this graph. And to find these two points, we use this just like ax squared plus bx plus c equals to 0 to find these 2 points. To solve this equation, we use to get the solution. If this one is greater than 0, then we have two solutions of this graph of this equation. If this one is equal to 0, then we only have one solution, like these two types. This one is the minimum point, and this one is the maximum point. If this one is less than 0, then we have no solutions.
I'm the third student, so the quadratic function is also useful in our life. Some shops use this function to get the maximum profit. For example, a clothing shop sells product for $10, which costs $8. They can sell 100 units every day. After doing the service, they find that if they reduce 10 cents per unit, their sales volume will increase 10 units. So we made a table below. From table, we can see the revenue for 1 unit, and before the service and after reduce X dollar. So we can get the equation. We use negative b divided by 2a to get the x for maximum y. So when x equals $0.5, the shops can get maximum profit $225 every day, and the price should be $9.5.
Quadratic equations lend themselves to modeling situations that happen in real life, such as the rise and fall of profits from selling goods, the decrease and increase in the amount of time it takes to run a mile based on age, and so on. Like the second part, Jay mentioned that something that can be modeled by quadratic is that you can easily solve the equation when set equal to 0 and predict the patterns in the function values. The vertex and the x-intercepts are useful. These intercepts tells you when numbers change from positive to negative or negative to positive. So, for instance, where the ground is located in a Phileas problem, or when you would start making profit or losing money in a bit entry. The vertex tells you where you can find the absolute maximum or minimum cost, profit, speed, time, or whatever you are modeling.